Hello ladies and gentlemen, my name is Decryption and I hope you are well. Continuing on with our racing script, we are going to make it now so that you can successfully have the characters running instead of walking, but the main focus today will be we're going to create a dev visualizer tool for the racing controller so we can specifically pick the starting points of all the different characters, which will make it look really nice, which we can make the characters walk to when the race starts, and then when it goes 3, 2, 1, they start off from their retrospective positions. So let's get started. So, you may notice I've changed it a little bit. I've not done anything functional. All I've done is added some walls just to make it look a little bit nicer. There is a gap here. I've added a guy here with a little flag, and eventually I'll record some animations of him waving the flag. That'll be cool. But everything else is still the same. They'll run down there. We've got it down here. A nice little gap. And the only other thing I've done is updated the minimap just so we can see it properly like so. I've not even fully updated it. Look, I've not done this wall. But yeah, so it's all there. That's all I've really done for the start. So how are we going to make these characters run? Now, there is a bunch of different ways we can do this. The main way is probably just to update the character's movement component and set their max walk speed. However, we can do better than that. So one thing in a game you'll have NPCs who share very similar stats. And this will be if this NPC's crouching, this is their speed. If they're running, can they crouch? Anything like that. And whilst we could hard code the numbers, if we were having a race with a big knight, he's going to run very slow. But then we might be able to add in some things that if he bumps into you, you'll go flying a lot quicker than the other ones. And this is all stuff we can build in, but what if we have two NPCs with the exact same stats? So this is where we want to build something generic, but yet easily modifiable. If you've watched my AI series, you know what we've already done is we've created these data assets for you to put characters' properties into it so we can put specific details about it. And I figured in this case it'd be a really good idea for us to set a racing behaviour almost. So we can say this character's running speed is this character's running speed is the same as them, so instead of duplicating all the numbers, just use this file again. Data assets are super awesome tools, and they're really easy to use. So, I'm going to go into my content drawer here. I'm going to go to my blueprints folder, and I'm going to go into my data assets folder. Just create them if you don't have one. Inside here, I'm going to right click, and I will create a new folder. I will call this folder stats. Inside this folder, I will create a new blueprint class, and it'll be a type of primary data asset. And I'll call this PDA Racing Stats. And I'll open this up. Inside here, it'll just look like a normal blueprint without a viewport, which is all good. So I'm just going to create some variables. So I'm going to say walk speed, and I'll set this to a float. I'll make sure it's instance editable. I'll also add a running speed. And because it might be a good idea for us to add some sort of stamina into it, because you don't want somebody to just run full bolt all the way throughout the course, because then it's going to be tough. You either make every move perfect or you fail. So we need them to have a sort of stamina that they're going to toy with eventually. So what I'm going to do is add one stat of jogging speed, and this is where they're going to slow down because they're overexerting themselves a little. And I'll just reorder it. So we have their normal walking speed, their jogging speed, and their running speed. I'm not going to add any variables into here which is going to be modified in the game. This is for static variables, almost like a data table, things that aren't going to change. So the stamina we will probably do in gas when we eventually add that into the system. So for this one, I think is all good for now. We could eventually add some animations here for winning animation, losing animation, maybe even some behaviour trees if we wanted to go that far, or some AI logic, so if they lose, maybe they get aggressive. That's something cool. So expandable. I'm going to complete and save that. Then inside here, I'm going to right click and I'll do miscellaneous data asset. And it'll say, what data asset do you want to create? I want to create our PDA racing stats. And I'll click select. I'll name this one racing stats underscore normal NPC. Just a standard NPC, really. And I'll open this up. So you can see we've got a nice little editor. So I'll say the walk speed is their current walk speed, which is max walk speed. So it's about 150. I'm going to take a guess that the jogging speed is about 300, and I'll take a guess the running is 450. We'll have to toy with those numbers later, but that is something we can look at doing. What I am going to do is I'm just going to come over to this guy here, just for proof of concept. And I'm basically just going to increase his mesh just by a tiny bit, just to show that he is a bigger character. Like that. So he is bigger, and he will run basically slower. That's the point of it. He'll walk slower, run a bit slower. It should work. And because we've done that, I will just Control or Command D, our data asset, and I'll call it large NPC. And I'll just play with the stats a bit, massage them. So he won't be as fast, but eventually he'll be able to do other things. So I'll do 125 for that, 250 and 400. So now we need a way to assign it to these NPCs. So I'm just going to come to my BP NPC. I will create a variable, and I will simply call it racing movement stats. And I'll name this our PDA racing stats. And I'll make it instance editable. And by default, I'll just give it a default, just because then it makes life a bit easier later. So I will set this to our normal NPC by default. So you'll see if I allow it to save out of source control. I can select this NPC. You can see she has a movement stats. I can also do the same for him, which I will set to large NPC, like so. So how do we go around changing it in the game? So it's actually really simple to do. All we really need to do is grab these stats, grab the item we want, such as running speed, and then set our max walk speed on our character movement. However, there is an optimized way we can do it to stop issues later. I'm going to come to my class settings, and I already have a BPI character interface here. If you've not got this already, simply come to your asset drawer inside your blueprints, create a folder called interfaces, right click, blueprint interface, and give it a name, something like BPI character or something, and then set a new function. So I will set this one to be called set movement speed, and then we need a way to pass into it what speed we want to actually set. Now we don't want to just hard code the number in, because we need to get this variable here. So we're actually going to do two functions, one to get the movement stats, and then one to actually set the character's speed. So now we need a way to actually tell the character what speed to go. We could just get the number or get this PDA and pass it back into it. But then we've got no way of telling what current state the character's in. Are they running? Are they walking? We're going to have to compare numbers, and it can get messy. So what I'm also going to do is actually create a movement state enum, so we can actually tell or query at any point what state the character is in. So if we're ever doing dialogue later and they're running fast, we can play some dialogue with them going, I'll win this, out of breath. If they're jogging, we can do it a little less breathy and be like, I'm going to get you. And then if they're walking, I don't know, they shouldn't be talking if they're walking really, they're in a race. But yeah, so I'm going to come to my blueprints enums folder, and I'm going to create a new blueprint enumeration, and I'm going to call it e_movement state. Inside here, I'll just add our three states, so add, and I'll call it walking, jogging, and then running. I'll save that. Now, back on our BPI character set movement speed, I can now pass in this enum, new movement state, and I will set the type to be our e movement state, and we don't need to pass anything back out of it, so we're all good. I'll compile that, and then back on our BP NPC, I will also add another variable, and I'll call it movement state, and I'll set this to our new e movement state, and we don't need it to be instance editable. We don't really need to edit it in the editor unless you want to default somebody, but that's really it. But now what you'll do is, if you've not got this interface added already, just go to class settings and find it here. But you will see inside the interfaces we now have our set movement speed here. And if we double click it, it will give us the new movement state. So now what we can do here is we can drag in the character's movement, and we can do set max walk speed. Oddly, Unreal doesn't have a set run speed, which is really odd. You'd think they would, but everybody just seems to use walk speed. So, yeah, you have to kind of manage that one yourself, but that's fine. Then from the float here, I'm actually going to drag backwards and say select float here. And you'll see it wants me to pass in a bunch of different ones. I'm going to drag backwards from this set walk speed, and I'm going to type select. And you'll see we've got a bunch of different ones. You want the one with this funky icon here, and click it. And now what this is going to let us do is pass in an index and select a variable amount of options. So if we pass in the enum, you see we now get to set what's the walking speed, jogging speed, and running speed. So what we're going to do with this is just drag in our movement stats, and I will simply do get walking speed or walk speed. I'll also do get jogging speed, and then finally get running speed. If we tidy it up a little and just add some more lines and such, like so, what we can then do is just simply have a nice way to go click, 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 like so. You might have some other moves such as, I don't know, maybe if you've got some potions that make you run faster, you can tune it up like that. But now if we compile and save, we've now got a nice tidy function at any point we can call and say, change your walking speed. Super simple. So what we can do is on event begin play here, which is disabled by default, we can just drag off and do set movement speed, and we'll use the call function one here, and it'll say what speed do you want. By default I'll just say they need to walk. So what this is going to do is, even though we've not set this NPC's walk speed, on event begin play, it will then set his walk speed for us. So we won't notice any difference at the moment. Look, they're all just happily stood there waiting for the race. But now, on our race controller, if we loop over these characters and say, set your movement speeds to running, they should now start running. So if we open this up, and then on start race, when the timer starts and it counts down, racers start running here. So where it says go, 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 and we loop over each race and give them an actor to follow, what we can actually do is if we just drag this across a bit before we tell them, and I'll just break off this one here, I'll connect the current racer into this just to make it look a little bit neater. But now we can drag off this current racer, and even though it's a type of character, we can still access our interface. We don't need to cast to it, meaning we can simply do set movement speed, like so. And then the movement speed we want is running for now. Eventually we'll make the AI state take over and make them jump between jogging and running depending on the stamina. But for running, when the race starts, everybody's going to bolt forward. Then we're just going to start jogging at the race where you're going to lose money. So if we try it now, and then we shift F1 to our race controller, and then click begin race, it should count down. 3, 2, 1, and then boom, they're running. They're stopping each one, which we still need to fix, but they are indeed running. And you can see the little one is indeed slightly faster than the bigger one because she has a fast walk speed. And they are... Oh, he's taken the shortcut. He might actually win this, ladies and gentlemen. This is an unprecedented event. Is he going to win? The big giant was clever and used his brain. And he took it. I did not expect that. That was actually quite good. I can't believe the giant one took it. So yes, there you go. We can eventually adapt these racing stats to be things like percentage to take shortcuts, so if they're more intelligent, for example, or percentage to cheat, percentage to bash the other player, stuff like that. So this is actually my third time of recording this next section, purely because I kept finding better ways to improve it, and it ended up just being this rolling mistake, so I started again, then I did it again, and I found something better. We actually need the racers to line up at the start line when the race begins. We don't want it to go 3, 2, 1, go, and the player's all the way over here and having to make up all this distance, because that's just going to be terrible. So what I'm going to do is modify this controller to basically have some set places where these racers who were part of the race can go to. But we need it to be visual for the developer, the editor, because we don't want them to have to just remember vectors. That's not going to be very useful. So I'm just going to hide these over here. So what I'm thinking we'll do is a new thing I found that I don't think is part of older Unreal versions. At least Google and ChatGPT don't think so. It only seemed to exist in C++ for the longest time, but now it's in Blueprints. So I'm going to come back to my race controller and I'm going to create a new variable called racer starting locations, and I'm going to set it to a type of vector. And I'm then going to right click it to turn it into an array and make it instance editable. You might have done this before, and you'll see if I click it, I can see the vectors here, but that's still not very visual. So the new thing is, if you come and click on the vector, you will have this Show 3D Widget option, and if you click that, it will now visualize those vectors in the engine here. And the best part is you can actually click them. I just press G to hide that. And you can move them into location like that. And as you can see, as I move them, the actual vectors update themselves. How cool is that? So now we've got a very easy visual representation. So if I had 4, where we can place the actors of the world. You can even, if you really want to, write some functionality where you can click buttons like create 4 grid and it'll create a 4, or create 8 race and it'll do a certain square or something. For me, I'm okay with this because I don't think my races are ever going to be that crazy. But if you want to see a tutorial on creating that, like formational grid things, let me know. I'll just position it like that. So now we've got nice, easy start locations. So how do we actually make them walk towards it now? So this is the part where we need to play it a little bit carefully, because we need them to arrive at this location before he says go. Okay, so that part makes sense. You've probably seen it on a few games where you tell an AI to go to a location, but they get stuck. It's like they've got to climb a mountain, there's an obstacle blocking them, the AI just messes up. Something like that. You've seen it before, and whilst we could sit there and say, we won't ever have that issue, you're probably going to have that issue at some point. Even Grand Theft Auto, the size of Rockstar, has issues where AIs can just glitch out. And with a race, we don't want the player sat here waiting over and over and over again for them to actually never be able to do it because it's soft locked. So I figured let's build something in to also disqualify anybody who doesn't arrive in time. You can make it part of the gameplay if you want. You also don't have to, you could just make it work. So what we're going to do is slightly modify our start race button to basically make this guy call out, the race is beginning, get to the starting positions. And then we'll start a timer. If all of these people in the race arrive at the correct time, it will just start the race. That's fine. We can also keep the timer going depending on how you want it to work. But if they don't arrive and the timer runs out, then we can disqualify them from the race because they're not at the race line when they need to. So if you think of, like, I'm guessing, I'm not an avid watcher, Formula 1, if you're not in the car ready to go when the buzzer goes, whatever, you can't race. It makes sense. So let's start off with actually telling them to go to their locations. That's the first part we want to do. So in the race controller here, I'm actually going to take all of the stuff here and move it down. And I'm going to add it to a new event. So add custom event. And I'll call it start race countdown timer. Nice long event name, but at least we know what it does. And then in the start race, I'm going to grab all of our races and I'm going to loop over them. Now, we could just get the location that we want them to go to, but I think it'll be a lot cooler if it's a bit random. So if we start this race here, we don't want this girl over here to always go to this spot. Maybe we want her to go over to this spot sometimes, because I think that'll be pretty cool. So what I'm actually going to do is drag in our racer starting locations, and I'm just going to call shuffle on it. And all it's going to do, in the game, not the engine, is randomise the locations of these 4. And then these are just going to randomly pick one. That's really it. But the thing we've got to be careful of is we don't want 2 different people to go to the same location, because that'll mess up. So that's why we're shuffling the locations. Equally, you could shuffle the races. Either way, it will work. So we'll shuffle that, and then we'll go straight onto the races. Then I'm going to get the racer starting locations, and I'm going to drag off, and I'm going to choose get a copy. And I'll plug it into the index here. The array index is what the current ID of this racer is. So if we've got 3 races, it'll be 0, 1, 2. And then this will go 0, 1, 2 as well. Now we've got the location, but that's the relative location. So if you look at the vectors here, that's saying this first one is at minus 70, but that's not in world position, because as you can see, we're at minus 3,000. That is called relative location, and we need to get world location. If we tell him to go to minus 70, he'll walk all the way over to where here is, I think it's here, 0, 0, and then 70 off, so like stand over here, and that's not right. So it's an easy fix transforming between relative location to a world location, and it is simply adding them together. So if I drag off this and do plus, and then drag back off of this and do get actor location, it will get the location of this world here, which is the driving force for these, and then it'll add this onto it, so it'll get the correct locations. And now this is where we run into a small issue, which is one of the reasons I had to restart the video again. And I did the same thing on my Gladiator Arena game. we could easily loop over all of these AI and simply tell them to go to a location. So if I go move to location or actor, I can easily do that like so and tell them to go there. But then we've got no way of saying which ones have arrived and which ones haven't. Because if we drag off of this move finished, it's asynchronous, which means it's not going to complete and the for each loop will get confused. And you can test this out. If you drag off of the array element, do get AI controller and connect it into there. If you print out the actor's name from move finished, like so, you will actually get the same actor's name 3 times. It's really, really weird. But that's because this is running asynchronously. It's running in the background. So what we actually need to do is create the character where we can tell them, go to this location, and then when they've arrived, tell us that they've arrived. So we're going to use an event dispatcher. So I'm going to come to my character here, and any character will do as long as it's a blueprint, and I'm going to open it up. I'm going to come and create a new event down below called go to location. Just something dead simple like that. Then I'll right click and do get AI controller. And the controlled actor will be self. And the return value will be move to location or actor. The one that we wanted to a moment ago. Then I'll plug the goal location into the event to create it. I'll also drop it down and also do acceptance radius. And if you want to do some others, feel free to. I'm just doing it like that. And we can tidy it up a bit like that. Now, what we can do is when they've finished, we can call an event dispatcher here. So I'll call this on go to location finished. I'll drag this in and choose call and plug that into the on move finished. If you've never used event dispatchers before, they're the best things in Unreal. They're often called delegates as well. The other thing I'm going to do is on this event dispatcher, I'm going to add an input which will have a name of character, and it will also have a data type of character. And it'll be a type of object reference, like so. And then I can drag off of this and just call self, like so. So now, when we tell an AI to go to a location, it can listen to the event dispatcher and bind to it, and be told back by the character when they've arrived. So instead of us sat going, have you arrived yet, have you arrived yet, we can say, hey character, go to this location, tell me when you've done. They'll plod on along, and then they'll say, hey, I've now finished, which is perfect, because then we don't have to worry about it. Now if I come back to the race controller, if I drag off the array element, you'll see we won't actually be able to get the go to location. And that's because this is a type of character, but this is a type of NPC. So what I'm actually going to do is go to my class settings, and you'll see I've got an interface here called BPI character. And I highly suggest you have one too, they're very, very useful. Super easy to set up if you've never done it before. Simply go to your content drawer, right click, blueprint interface, give it a name. Open it up. In here, I'll add a new function called go to location. And then I'll add the same inputs I added into the one here. So a vector and a float. So I'll call this one goal location. You can really call it anything you want, but it makes more sense if you follow it. And I'll set it to a type of vector. I'll set this one to be acceptance radius, which will be a float. And we can compile and save. And now back on our NPC, just simply go to class settings, add it if you've not added it already. But now what this means is I can delete this custom function, and inside interfaces, I've now got a go to location I can double click. It looks identical, but the benefit it gives us is we no longer need to cast to the NPC. So if I compile and save, now back on our race controller, I can simply drag off and type go to location, like so. And because this is no longer asynchronous, it's handing the parallelity? Is that a word? The asynchronousness of the task over to the NPC, so the controller doesn't have to worry about it. So how do we actually do it? Now normally in this video I go interface, we'll create an interface. However, what we actually need to do is to tell the NPC to go to a location and then tell us when it's done. It wants to tell the race controller. If you create an interface, you can't use event dispatchers, and casting to the NPC will just subvert the whole point behind using an interface anyway. So what we're going to look at is using an actor component. instead, which will allow us to get just that component on the NPC and say, do something, go and tell them to go somewhere. So what I'm going to do is come back to my blueprints folder, and inside my components, I'm going to create a new blueprint class, and I'm going to click actor component, and I'm going to name this AC for actor component, and I will name it movement controller, and I'll open this up. So it's going to kind of look like a normal blueprint, except you won't have a viewport, which is fine. But what I'm going to do is create a new event in here. So I'll go add custom event, and I will call it go to location. From this, I will right click and do get owner. I'm going to cast this to a type of character, because a character is one of the lightest things in Unreal. So casting to it, you already have a character built into the engine anyway, so it's going to be nothing. If its cast failed, then we know somebody's attached this component to something that can't walk around the scene. A character can walk around. A normal actor, they might be able to, but by Unreal standards, they can't. So I'll say, this actor cannot move around. This will stop people attaching it to like a garbage bin, a trash bin or something, and then expecting it to move around. We can't have that, unless they want that, obviously. Then from this character, I'm going to drag off and do get AI controller. And then from this AI controller, I'm going to drag off and do move to location or actor, our asynchronous function. The goal location, I'm just going to pop into the go to location here. And the same thing for the acceptance radius. I'll plug that in as well. It'll look a bit messy that we've had to drag them all the way over. There's not really a great way to fix it. You can't have this asynchronous function inside a function, ironically, because it's asynchronous. Functions don't allow delayed calls. Events do. So now that we've done that, what we can do is when we've finished, we can broadcast to anybody who's listening, hey, we've finished. Basically like shouting. So the race controller will tell this component, go to this location, and tell me when you're done. And when the component arrives, it will go, hey, controller, I am now done. I have arrived. So how do we do that? Event dispatchers. So let's call it on go to location finished. And then I will pass an input back of a type of character. And I'll set it to a type of character as well. I will name it character and set it to a type of character. And then I can drag this in and choose call. And I can plug it in like so. The character, I will drag this character over here into it and just try to neaten it up, I guess. Like I say, you can't massively neaten it up. The reason we're passing the character back is we want the component to say, hey, I've finished, but the race controller's then going to say, who's finished? I'm just hearing people shout, I'm finished. So we can pass back the character saying, hey, this character has now finished going to their location. And then we know they've arrived at the correct destination where they need to go. So if we come and add this movement controller back to our AC movement controller, that's all we need to do. Compile and save. Back on our race controller, we can now get to the character, and this is where we don't need interfaces or casting. We can simply do get component by class. And make sure you choose component and not components, because there's only one component. Give us a bit of space. The component will be our AC movement controller, and the return value will simply be go to location, like so. The location will be this one here. The acceptance radius, I'll set it to like 50, and we'll try it. We need to be careful because the root of this character is in the middle there. We need to make sure that that distance there to the floor where this location is enough that they can intersect, so less than a number. So if I place him exactly here, we need to make sure that that distance is 50 or something close to it. But we can play with that just to see if we're right. And then the final thing is I will drag off the component again and do assign on location finished, like so. And this is the broadcast to say tell me when you've finished. So this is saying tell me when you finished. This one is saying I finished, and that's the character. So now when we call start race, it will shuffle the locations. It'll tell everybody to go to that location or a random one. Then it'll tell us when they've arrived at it, what do we need to do. This is where we need to start tracking the racers that's actually arrived at the correct destination. They've arrived to where they need to go. So I'm going to come and duplicate the racers variable, and I'm simply going to call it racers ready. I'm going to make it private because we don't need to see it, but I will keep it instance editable just so we can see it for now, because it'll be useful for debugging, and then eventually we'll turn it off. Then I'm going to drag this racers ready in, and I'm going to call add, and I'm going to plug it in to the character like so. So now every time a character arrives, it will add them to the racers ready. But now we need to actually check, has everybody arrived? Because if everybody's arrived, there's no point us waiting anymore. We may as well start the race. So I'm going to grab the racers ready, and I'm also going to grab our racers, and I'm going to check if they have the same length. So I'll say equals. I'm going to drag off and do get and do length, and I'll do the same for the racers here. And then I can drag off of both of this and say equals. So in theory, if we've got 5 racers and the racers ready equals 5, everybody's arrived. So we can just pump it here like so. If you don't want this functionality, if you want a timer to go off to count down, 60 seconds for everybody to arrive, but no matter if everybody's arrived, you want everybody to have to still wait 60 seconds, that's your game. Don't put this bit in, just leave it. Just leave it like that. We'll do the timer in a moment. But for those of you that want it where when everybody's arrived, the race just jumps straight into starting, we can do it this way. So when everybody's arrived, if it's false, ignore it. Everybody's not arrived yet. If it's true, however, I'm going to come and take our start race countdown timer and call it straight away. There. Everybody's arrived, start the counter. One final tweak I'll do before we move on to the timer, however, is here we've got the component and we've bound an event to it. After the race has arrived at the race, we don't need to know anymore. So we actually want to unbind our event. So I'm going to copy this get component by class and just paste it down here like so. And I'm going to add our character back into it, so the character who's arrived. And I'm simply going to type unbind event from go to location finished. Don't use all events, it's a very dangerous node, that one, because if you've got other things listening to a character, say a quest, it's going to go bad. So all you need to do is just unbind this singular event from it, like so. And that'll tell our race controller, they've arrived, you don't need to wait for them to arrive anymore, you don't need to listen anymore, really. There we go. So the final thing is the timer that I mentioned, the soft lock protection I will call it. If we tell all these actors to arrive at this destination, but one's in prison, he can't arrive, we don't want the game to freeze. Well, it's not going to freeze, it'll soft lock, that's what it's called. So how do we get around the soft lock? And it's actually really simple to do. All we're going to do is start a timer as soon as all these people have been told where to go. Then we're going to set some time, whether you want to calculate it. I'm just going to set a time of like 20 seconds. Everybody get to the start line. You could equally do it based on somebody's distance away. So if you get the maximum person's distance, multiply it by some movement speed, you could probably roughly calculate how long it would take them to get there. But equally, it's a great way to stop soft locking. So I'm actually going to come and copy this set timer by function name and the set countdown timer down here. And I'm going to paste it just here and plug it into the completed there. When this timer gets called here, I'm going to simply add a function called racer arrival timeout. Yeah. I'll set the time to be 15 seconds. And I don't need it looping, it just needs to run once. And I will create it as a variable there. And the reason we're setting it is so we can cancel it if everybody arrives. So let's do that now. So if I come over here, if everybody's arrived, we don't need this anymore. So I'm actually going to grab the countdown timer and just call clear and invalidate. So if we tell 5 racers to arrive at their destinations, but for some reason they're already there, then this timer will just be cancelled and then the real timer will start. What we don't want is this timer to count down, this timer to also start, and then this cancel it and, it doesn't need to run anymore. So that's why. So the final thing is, let's implement this function, racer arrival timeout. So I'm going to create a new function and paste it in. So this is that we need to check if all the racers have arrived, and anybody who hasn't arrived is disqualified from the race. So I'm going to drag the racers in, and I'm going to do a for each loop over them. And then I'm going to drag off the array element. Then I'm going to drag in the racers ready, and I'm going to do a contains item, like so. And I'm going to plug it into there. If they are contained in the racers ready array, true, then it means they've arrived. We don't need to do anything. However, if it's false, then it means they've not arrived yet. So we need to add them somewhere so we can go, you're disqualified. So what I'm going to do is create a local variable called timeout races, purely because I don't know how to spell disqualified, and it sounds like a horrible variable to have to keep typing. So I'll set this to a type of character, and it'll be an array. Then I'll drag this in like so, and I'll choose add, and I'll plug in the character we've got here and the false into it. So we're looping over all the races and saying, hey, you've not arrived, you're disqualified, so we add it to there. And then on the completed, we're going to loop over the timeout races and start removing them from the race participants, really. And the reason we can't do it directly on the races is if you modify an array that's currently being iterated, it can go very, very bad because you are going to lose your position. Some languages will just outright say, no, you can't do that, it'll error. So you need to be careful. So that's why we're doing two loops. One to find the disqualified, and then one to actually disqualify them. And to disqualify them, there's multiple things you can do. I'm simply just going to come and do remove item, like so. So we're going to remove them from the race participants. This will only do it in the game. It's not going to do it in the editor, so don't worry about losing stuff that way. Just for niceness, what I'm also going to do is just add a print statement, and we'll say something like append, and then we can say racer, and then we'll grab the name, and we'll say has been kicked out. Yeah. Again, because I can't spell disqualification, it's a big word. Yeah, then the last thing we need to do is we've disqualified all the actors, we've looped over all the racers, we've disqualified them. At this point, we can start the race. So let's drag it in and hit continue. The reason we have to do it here as well, instead of just this one over here, is if we've disqualified racers because they've not arrived, this is never going to get called. Which is why this one, after it's disqualified people, will officially kickstart the race. So ladies and gentlemen, we've got our racers. Let's move this guy, well, a duplicate of him, all the way over there. He's got no chance of making this. Gary, over there, got so drunk the night before that he went to the wrong place. So he can't actually join the race. Well, he thinks he can't. He might actually be able to arrive. So let's click play and see what happens. You see, everything's normal. If I go to my race controller and click start, they will start walking to the location. There we go. And you can see he's trying to, but slowly. And they've arrived at their destinations, hopefully. Have I exposed that variable? I'm pretty sure I did. So I'm just going to pause the game. And have we got a private thing here? Racers ready. There we go. Yeah, so we've got two racers, NPC2 and NPC. So if I break out of this a moment and click them, NPC2 and NPC. Perfect. But NPC4 hasn't arrived yet. So let's see if he arrives before he's disqualified. If you look at the corner, oh, he's been disqualified and it's now counting down and they will go to the same location. But they are running. There we go, ladies and gentlemen. We have disqualified the drunk guy because he decided that, he's still trying to go there, but they are already running the race. Look, very glitchy because of the NPC optimization tool, but you can see they are running. If I shift F1 and pause it, click back on our race controller a moment, you can see he has officially been kicked out of the races. If I escape to quit the game, click back on it, you can see he is still part of it. There we go, ladies and gentlemen. How cool is that? We now have a dynamic visual race point system where we can add race starting points. You can have up to 4 people. Then we've got our disqualification soft lock protection, call it whatever you want, which is really going to be helpful for, we're on 30 minutes at the moment for this part 2. For the sake of 30 minutes, to add a soft lock prevention into your game is pretty good. The other thing I will do is if they are disqualified, I think I'm just going to tell them as well to stop active movement, because they don't need to keep walking to the start line. They've already been disqualified. We may as well save the resource, haven't we? So I'm just going to tag that onto the end of there. It's a bit messy and we could tidy it up a bit, but we'll be okay for now. And there we go. That is the second part to the race tutorial series, ladies and gentlemen. In the next part, we're going to be looking at adding winners and losers to the game. So as they run around and they arrive back here, we can say winner, loser, kind of thing, whatever we want to do. And then we'll eventually start looking at either integrating or not integrating the player into it. So if the player's integrated, they will have to get to the race location, otherwise it'll be mission failed. We'll disable their inputs so they can't move around until it's time to go. And then when it says go, the player will have to run around. We'll track their progress as they go around it. And then whoever gets back here first is victorious. All coming up, ladies and gentlemen. Subscribe to see more of it. Thank you for watching. I hope this helped. If you've got any issues, please reach out in the comments or over Discord. I do have a Patreon where I give away animations and you get access to some of the tutorials up to months early sometimes. Thank you for watching. My name is Decryption and I will see you and Drunk Gary next time.